In Blaisdell circle notation, there's a different way to write functions. Now, a function is written as the function's representation, the variable it uses, its grade, its iterations, and its repetitions. Now, if you have a function of x, n, I, 0, that is just equal to f of x in the normal way of writing functions. But n, I, and r are defined by the following equation. F of x, n, I, r plus 1 is equal to f of x, n, I, r, half circle, n, f of x, half circle 1, I, n, I, r, all half circle n plus 1 of I. And this is the generalized fundamental theorem of calculus in Blaisdell circle notation. Now, one thing that's nice about Blaisdell circle notation is any expression can be written out in one line because there is nothing to make it multiple lines. So, if there is ever a calculator made for Blaisdell circle notation, then everything can be written on one line. Now, if you plug in some values for this, you can find some very interesting things. Now, the basic derivative is f of x, grade 1, interval 0, and repetitions 1. Because the interval is 0, so plugging in numbers would give you f of x minus f of x minus 1 minus 0 over 0. Now, because you can't divide by 0, you'd make these h's or change in x's and make it the limit as that approaches 0. So that is the fundamental theorem of calculus that is normally used by plugging in 1 for the grade, because that would be a 2, which is division. That would be a 1, which is subtraction, because they're half circles. And with a 0 interval, that is that. Now, you can also go backwards, which instead of a 1 repetition, a negative 1 repetition is the antiderivative, or indefinite integral, of f of x dx. And then that's with a different number of repetitions. Now, if you use the same thing, grade 1, interval 0, and repetitions as n, that is dn over dnx f of x. So, if n is 2, that's the second derivative, and like that. But what if the number of repetitions is a negative 1, and the grade is 1, but the interval is 1 as well? So, this is equal to the indefinite summation of f of x. which is really cool. And if you do this with a positive repetition, that is equal to f of x minus f of x minus 1, which is the opposite of the summation. But all of these have a grade of 1. It can have a grade higher than that. So, grade of 2, interval of 1, and repetitions of negative 1, that is equal to the capital pi of f of x. Now, capital pi is like sigma, except instead of adding all the numbers together, you're multiplying all the numbers together. And the opposite of this, by plugging all the numbers into here, and it's opposite because the repetitions are positive instead of negative, that is the first root, which you don't even need that because it cancels out, of, so it's f of x